What's up, 8th grade? Mr. Agnos here, and this is a homework help video for homeworks 8-2K and 8-2G. All right, so looking at number 1 here, it says find the rate of change of the linear function, and then it gives us a graph, and it even gives us 2 points. So really, we need to recall from class that when it says rate of change, they're just asking us for the slope. Right? This is a synonym for slope. A synonym is 2 words that mean the same thing. Except rate of change, we would use the term rate of change when we're actually measuring something, right? If I'm actually measuring the height of a tree over time, right? I don't say what's the slope of the tree. I would say what's the rate of change? How much is it growing by per week or per year? And then also recall that linear function, this is a synonym for linear equation, right? When they say linear function, this is the same thing as linear equation. So here, we're just going to use the same, we got new vocabulary, right, rate of change, but we're going to use the exact same skills that we studied in topic 5. We'll make a slope triangle here. I have 2 points, so how do I get from the one on the left to the one on the right? The first thing I'm going to do is go down, and remember, anytime we go down, we're going to have a negative rise, right? M, remember, M is slope, but it's also, right, this is the slope or rate of change, right? They're synonyms. So the slope is rise over run. And in this case, our rise is going to be negative because we're going down. Now be careful. Let's make sure we check the scale of our graph here. They're not going by 1s, they're going by 2s. 2, 4, 6, 8, 10, 12. So I went down 2, 4, 6, so that's a -6. -6 on top. How far did I go to the right? Again, don't just count the boxes, you have to check the scale. So they're also going by 2s on the x-axis. 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's my slope or my rate of change. They want me to simplify. Always read this blue writing here. It tells you how it wants the answer. A lot of times, every year, kids get questions wrong on homeworks, on tests, because they just don't read the blue writing here. I need to simplify this. All right. Well, -6 and 18 have a common factor of 6. Right? So I can divide the top and bottom by 6. And my final answer, -6 divided by 6 would be -1. 18 divided by 6 would be 3. So this problem, so that's my rate of change, -1/3. So this question right here, really similar to what we did in topic 5, except some new vocabulary. All right, I'm just going to scroll through here and point some things out. Number 2 is pretty much the same as number 1. All right, number 3, they're asking you to find the equation of the linear function. Remember, we write equations in y equals mx plus b form. Okay, I'm not going to do this whole problem, but I'm just going to get you started. So we know we're going to write our equation in this form. And anytime we write an equation in this form, we need to find 2 things. We need to find the slope, the rate of change, and we need to find the y-intercept. So you're going to go ahead, you're going to look at your graph, you're going to identify the y-intercept. What is it? They actually give you 2 points here, so you're going to go ahead, make a slope triangle, figure out the rise and the run. Once you get these 2 numbers, you're just going to plug them in, right? Whatever that number is, you're going to plug it in for m. Whatever this number is, you're going to plug it in for b, and you will have your equation. Moving right along. All right, number 4, they just give us an equation. They say find the rate of change of this linear function. All right. Might be confusing at first just because you haven't seen a question like this, but this is actually ridiculously easy. Rate of change means slope. The equation they give me, y is equal to 4x minus 7, is in slope-intercept form. Right? It's in y equals mx plus b form, where this is my m, and this is my b. Remember, if they were asking about the y-intercept here, we'd have to include this negative. So my rate of change or my slope is just 4. Right? You literally just have to look. What number is being multiplied by x? Okay, and that's going to be your rate of change. That's one of the reasons why having equations in this form are so good to work with. All right, we are going to see some new stuff here in a second. All right, so in this topic, we start seeing tables. Okay, tables are another way. This is a table, right? Table of values. It's another way of showing a relationship between two things, right? And I've actually made some tables this year. I've generally made them vertically, right? So remember I made this table earlier this year where I said, hey, X is the number of touchdowns and Y is the number of points. And I made a little table, and I would say, okay, 0 touchdowns is 0 points, 1, 6, 2, 12, right? And from this table, we can figure out the relationship between touchdowns and points, right? All right, well, here we have a table, and it's arranged horizontally, okay? So it's a little different, but we're going to use it the same way. So it says a homeowner ran a new generator and measured the depth of gasoline in the tank hourly. All right, a generator is something that produces electricity by using gasoline. It's like an engine. Think of it as an engine, right? And then you can get electricity from it for like when the power goes out. So hospitals, police departments, they all have backup generators. So when the power gets knocked out, it does not go out at the hospital or at the police department because they have backup generators that immediately kick in. And it uses gasoline. Well, whether it's a generator or a car, the more you use it, the amount of gasoline goes down, right? The amount of gasoline goes down. All right, so that's what we're measuring here is, hey, as we use this, so look at the top row here. It says we're measuring time in hours. And as the hours go by, right, there's 1 hour, 1 hour, right? So we're measuring every hour, right? Every time we move to the right, we're measuring by 1 hour. What's happening to my gasoline, right? The depth of the gasoline. Well, after 1 hour here, it went down. Okay, remember, because it went down, we're going to use a negative number here. I went from 33 to 28. The amount of gasoline in the tank went down 5 centimeters, right? We're measuring the depth of the gasoline in centimeters. 28 to 23, I went down. So we can see that every hour, the amount of gasoline in the tank is decreasing by 5 centimeters, right? The depth. All right, when you use a table to write a rate of change or a slope, we still have a rise and the run. The top row, those are always considered your x coordinates, what we call our inputs. These are always our x coordinates, and the bottom row is always our y coordinates. So when you actually go to write a rate of change here, we say, okay, our y values, right, are actually changing by -5 each time. So if I was going to write a slope or a rate of change to represent this table, this -5 actually goes on top, and the 1 comes to the bottom. And what this says is that we're losing 5 centimeters, minus 5 centimeters per 1 hour. So sometimes this little switcheroo from top to bottom messes kids up. So be careful there. It's going down 5 centimeters every hour. And they want us to simplify your answer, so we would just write this as -5, right? -5 centimeters. Got it. Okay. I think we're going to do one more like this, where there's a little wrinkle. So here's another one where we have a table of values. So that's similar to the one I just did. These are all similar to the ones I've done already. All right, look at this one. Got to be careful here. we're not increasing by 1 every time. We're measuring the thickness of something, of a grinding pad, and as you, grinding pad might be something that you use to sand or to grind something down. The more you use it, sorry, my buddy's texting me. The more you use it, the thinner it gets, right? In other words, you use it up. So as time goes by, the thickness is going down. Well, notice with this table, it's not going by 1s, it's going by 2s. So we're actually taking a measurement every 2 weeks, right? So when I go to write a rate of change here, right, I'm going to have a 2 on the bottom, and then we're going to have to simplify. So let's see, I went from 44 to 38, so I went down 6. And you can see that every time we're going down 6 here. So it's getting 6 millimeters thinner as we use it up, all right? And so that -6 goes on top, and then you need to simplify this, right? So our rate of change is -6 over 2, right? This means -6 millimeters, that's 2 m's, every 2 weeks. You would simplify it to, let's see, they're both divisible by 2, so that'd be -3 millimeters every 1 week. So they don't always go by 1s here, so be careful of that. And I think there's one more that I wanted to show you. Not only do they not go by 1s every time, but sometimes they actually change the amount. Don't let the decimals freak you out on number 10. Okay, just go ahead and figure out, right? You use a calculator. What's happening here? How much are we changing by each time? I think it's on the last question where they give you a table. And notice that the amount of time here, or I'm sorry, it says the length of the lines and the depth of paint. Notice that the amount of time here, the first time we go by 3, the second time we go by 2, the second time we go by 3, and the third time we go by 4. So when you go to figure out the rate of change here, it's going to depend on which 2 points you pick to use. All right, if I want to figure out the rate of change, you know, from between these two right here, I got to make sure I have a 3 on the bottom. But if I go to check the rate of change between these two right here, I got to make sure I have a 2 on the bottom. And if I go to find the rate of change between these 2 points right here, I got to make sure I have a 4 on the bottom. In other words, I got to make sure I'm dividing by the correct number. So this one's kind of tricky. I'm not going to do it for you. I want you guys to struggle. I want you to chew on it a little bit. But it's essentially the same process as the other two that we looked at. Just make sure that you use the correct number on the bottom of your ratio when you're writing your rate of change. Okay, as always, this video is just to give you a little bit of help. It's not meant to answer all your questions. It's not meant to do the problems for you. You're supposed to struggle, right? Embrace the struggle. Make sure you're asking questions in class, and I'll see you guys soon.